Welcome to Selection with Sathi. Today we learn how to construct binary trees from traversal sequences. This is one of the most frequently asked topics in GATE CSE. We will cover building a tree from Inorder plus Preorder, Inorder plus Postorder, constructing a BST from Preorder Alone, and serializing and deserializing binary trees. All with code on screen and step-by-step dry runs. Let us begin. To build a tree from Inorder and Preorder, the key insight is the first element of Preorder is always the root of the current subtree. Look at line 4, we pop the first element from Preorder. That is the root. Line 6, find this root in the Inorder array. Everything to its left belongs to the left subtree, everything to the right belongs to the right subtree. Line 7, recursively build the left subtree first, using the left partition of Inorder. This matches the Preorder pop order because Preorder visits node, then left, then right. Line 8, then build the right subtree. With a hash map for the Inorder index lookup, this runs in O of n total. Building from Inorder and Postorder is similar but with two key differences. First, in Postorder the root is the last element, not the first. Look at line 4, we pop from the end of Postorder. Second, we must build the right subtree before the left subtree. Why? Because Postorder is left-right node. When we pop from the end, the next elements are the right subtree, then the left. Look at line 8, right subtree is built first. Line 9, then left. If you build left first, the popped elements will be mismatched. This is a common mistake in interviews. For a BST, we do not even need the Inorder traversal. Why? Because the Inorder traversal of a BST is just the sorted version of any other traversal. So Preorder alone contains all the information. Look at the bounds-based approach. We maintain a range, low and high. Line 6, if the next Preorder value is out of the range, return none. Line 8, otherwise, create a node. Line 10, for the left child, the upper bound becomes the current value. Line 11, for the right child, the lower bound becomes the current value. We process Preorder left to right using a global index. This is an O of n single pass algorithm. Very elegant. Serialization converts a tree into a string. Deserialization rebuilds the tree from that string. The trick is to include null markers. Look at line 3. When we hit a none node, we output a hash symbol. Lines 4 through 6, otherwise, output the node value followed by serializations of left and right subtrees. This Preorder traversal with null markers uniquely defines any binary tree. For deserialization, look at line 9, split the string by commas and create an iterator. Read tokens one by one. If it is a hash, return none. Otherwise, create a node and recursively build left then right. Both operations array O of n.
Let us build a tree from Inorder 4, 2, 5, 1, 6, 3, 7 and Preorder 1, 2, 4, 5, 3, 6, 7. Pop 1 from Preorder. Root is 1. Find 1 in Inorder at index 3. Left subtree Inorder 4, 2, 5, right subtree Inorder 6, 3, 7 pop 2. Root of left subtree is 2. Find 2 in left Inorder at index 1. Left of 2, Inorder is 4. Pop 4, it is a leaf. Right of 2, Inorder is 5. Pop 5, leaf. Pop 3. Root of right subtree is 3. Find 3 in right Inorder at index 1. Left of 3, Inorder is 6. Pop 6, leaf. Right of 3, Inorder is 7. Pop 7, leaf. Result, tree 1 with left 2 having children 4 and 5, right 3 having children 6 and 7. Same tree, but now using Inorder 4, 2, 5, 1, 6, 3, 7 and Postorder 4, 5, 2, 6, 7, 3, 1. Pop 1 from the end of Postorder. Root is 1. Find 1 in Inorder at index 3. Now build right subtree first. Right Inorder, 6, 3, 7, pop 3 from Postorder end. Root is 3. Find 3, split into 6 and 7. Pop 7 from end, right child of 3 is 7. Pop 6, left child of 3 is 6. Now build left subtree of root. Left Inorder, 4, 2, 5 pop 2 from Postorder end. Root is 2. Pop 5, right of 2 is 5. Pop 4, left of 2 is 4. Same tree reconstructed, 1 with left 2 and right 3. Notice we built right before left, matching the Postorder pop order. Build BST from Preorder 8, 5, 1, 7, 10, 12. Start, bounds are minus infinity to infinity. Value 8 is in range. Create node 8. Index becomes 1. Build left, bounds minus infinity to 8. Value 5 is in range. Create node 5. Index becomes 2. Build left of 5, bounds minus infinity to 5. Value 1 is in range. Create node 1. Index becomes 3. Build left of 1, value 7 is greater than 1. Out of range. Return none. Build right of 1, bounds 1 to 5. Value 7 is greater than 5. Out of range. Return none. Back at 5. Build right, bounds 5 to 8. Value 7 is in range. Create node 7. Back at 8. Build right, bounds 8 to infinity. Value 10 in range. Create 10. Right of 10, value 12 in range. Create 12. BST, 8 with left 5 having children 1 and 7, right 10 with right child 12. Serialize tree, root 1, left 2 which is a leaf, right 3 with children 4 and 5. Preorder with nulls, visit 1, go left to 2. 2 has no children, 2, hash, hash. Back to 1, go right to 3. 3 has left 4, 4, hash, hash. And right 5, 5, hash, hash. Full string, 1, 2, hash, hash, 3, 4, hash, hash, 5, hash, hash. Now deserialize. Read 1, create root 1. Read 2, create left child 2. Read hash, left of 2 is none. Read hash, right of 2 is none. Read 3, create right child 3. Read 4, left of 3 is 4, both children are hash none. Read 5, right of 3 is 5, both children hash none. Original tree perfectly reconstructed.
Quick exam tips for tree construction. First, Gate Classic, Inorder plus Preorder uniquely determines a binary tree. But Preorder plus Postorder alone is not unique for general binary trees, only for full binary trees. Second, for BST, Preorder alone is enough because Inorder equals sorted Preorder. Use the bounds method for O of n construction. Third, Inorder plus Preorder builds left first. Inorder plus Postorder builds right first. Mix up the order and you get wrong results. Fourth, serialization with null markers makes Preorder unique for any tree. This is the standard codec used in leet code and interview problems. That covers tree construction from traversals completely. These techniques are some of the most elegant in all of DSA. For more concept videos with code walkthroughs, download the Selection with Sathi app. Like and subscribe. Thank you.